22,000 miles away from Earth, the GOES satellites keep a watchful eye on our planet at all times, sending real-time data to help predict weather days in advance. At the same time, instruments carried on board GOES monitor our sun and provide critical data for space weather prediction. You may then ask yourself, why do that? Why do we care?
When you think of space weather, and they talk about things like solar wind, it's not the wind that you breathe. This is radiation that's coming off of the sun. Protons, electrons that come streaming off of the sun towards the Earth, and they get caught in the Earth's magnetic field. They get mirrored down to the poles. You see the aurora borealis. They heat the Earth's environment and it cools. And so that heating and that cooling certainly has an impact on our Earth-based weather.
You may not know it, but you can have a solar storm and all of a sudden you're pumping gas with your credit card and it's not working in the machine. That can be from a disruption in communication satellites from solar weather. The solar weather affects you every day down here as well, not only just astronauts, it affects people on Earth.
In fact, space weather data is so important for everyday life here on Earth that there are people who actually monitor that data 24 hours a day, 365 days a year.
Hello, I'm Howard Singer, Chief Scientist at NOAA's Space Weather Prediction Center here in Boulder, Colorado. We study the space environment and provide information about what's going on in space and on the Earth that's influenced by our sun. The antennas that you see behind me are used to capture data from the geosynchronous satellites, the GOES satellites, that are over 22,000 miles above us here in Boulder.
This is manned 24/7, 365. Space weather can happen at any time. The forecasters assimilate all this data to develop both a probabilistic forecast for the next 24 hours. The forecasters can also issue alerts and warnings in real time.
The people that use our data are the power companies because space weather can actually cause problems for the power grid and blackouts. NASA uses our data to let the astronauts know to go to a safer place.
Typically it has to be clear to go out on a spacewalk because you do subject yourself to even higher radiation because you're not shielded by either the shuttle or the space station.
Also, GPS users use our data because space weather can increase errors in GPS data. We can do things like warn planes that if they fly at a certain latitude, they will lose communications. Or we can let satellite operators know that radiation levels are high and they can operate their instrument in a way that will make them less susceptible.
All of these new customers, these new technologies now depend on space weather in order to protect their systems.
Other satellites, such as STEREO, SOHO, and SDO, are dedicated to help scientists study the sun. Space weather forecasters use that data as well to create different models. So why then would a weather satellite like GOES need to also look at the sun?
SOHO, STEREO, SDO going up, they're all NASA experimental satellites looking for scientific data. GOES is actually operated by NOAA. We develop it here at NASA, and they're operational satellites.
So that means that there's always 2 satellites running at all times, and should one of those fail, that there's even a 3rd satellite up there in storage waiting to be turned down. So we will never miss some space weather event that's going on.
0 and liftoff of the Delta IV rocket.
On March 4th, 2010, NASA launched the last satellite in the GOES NOP series. GOES P, now GOES 15, will ensure continuity of service and delivery of real-time data to help predict space and Earth-based weather more accurately.
We're actually working on the replacement of those, the GOES R series, and they're going to be lasting for 5 years of storage and 15 years on orbit.